Hello everyone. Today we are going to discuss about electrical grounding system. We know in electrical power system grounding is important. Whether it is a solar panels or whatever different system, the grounding is important. So in future videos I will explain about how to ground the solar panels. So before that we need to understand the basics of grounding in electrical system. So this video is dedicated to teaching the basics of grounding system. So first thing, what type of material we need to use for grounding? So we are using low impedance material because the principle of grounding is to provide the low resistance path or low impedance path for the electricity to flow. So whenever there is a short circuit phenomena happen, we don't want that the wires burning or anything. We want to divert that short circuit current to the ground. Very simple. So if you want to divert that short circuit current to the ground, then the current carried to the ground, the conductor which carry the current to the ground should be capable of quickly uh, carry that current. So it means like we need a low impedance conductor. So the copper is one of the material which has a very low impedance. So it's been a very good conductivity. So that's why we are using copper material here. So electrical grounding system, what are the important things? There are two different types of grounding. There is a equipment grounding and system grounding. Equipment grounding means that we are, if you look at all equipments, there's a connection, there's a screw is there where we connect the ground cable at that equipment. Many major laboratory experiment kits or any big equipments, even small equipments we are using in the house. So it as a matter of fact, each equipment should has the grounding place. So it means what we are doing is to create a low resistance path for the equipment to connect to the earth. It means when let's say you are doing some experiment in particular equipment in laboratory, if there's a fault happen, we don't want that equipment to burn out or to receive that fault current. So what we want that the equipment should capable of quickly divert that fault current to the ground. So equipment should be grounded so that if any short circuit or any phenomena happen, you know that the outside metal also you can feel the the current. So what means that we need to divert all the fault current to the ground. So that's a matter of equipment grounding. So now, second thing is system grounding. System grounding mean at one place we have to connect the neutral. Most of the cases we connect the neutral to the ground rod. That's we call bonding. So in we have to earth all the equipments. Then we have to ground the neutral neutral connection in the main switchboard to the ground. So it means we are closing the earth loop. It means that system grounding means we are making sure that loop is complete. I mean, it's not just diverting the current to the ground. If just diverting the current to the ground mean, if there's a question you may ask where that current going to go in the ground, where it's going to go. It means the answer is system grounding. System grounding means we are getting that current back to the neutral which is available, neutral bus bar which is available in the main switchboard. So the idea is that whenever there's a short circuit phenomena happens, so we divert the current to the ground and receive the current through the neutral which is in the main switchboard. So main switchboard we do the neutral grounding. That's we call bonding. We will study this new terminology in future videos. So that's the thing. So here you can simply see the equipment grounding. In many equipments it is a compulsory, but some like 10 years before many equipments are not grounded because of not proper education or awareness available among the installers or electricians. But nowadays, if we look at most of the equipments we are using, we have a grounding, a proper grounding is maintained. So that's good. So what happened here? If let's say there's a short circuit, any phenomena happens, there's a current flowing through the metal parts or the metal cover of the equipment. That current is quickly diverted through the ground wire to the ground. Okay, that's a equipment grounding. So system grounding. So we have three methods depending on the configuration of location of solar PV system. Different grounding methods may be used. So we have three different grounding method: direct buried method, ground ring method, and concrete enclosed method. So there are three different methods for system grounding we are using here. So we are going to look at one by one, but other these methods for system, the grounding. These are the grounding methods. Okay. So direct buried method means that we just this is in the most of the houses we are using this method. We are putting the rod, the copper rod into the earth. Very simply, we are connecting this copper rod to the earth. This is our grounding. This is our grounding. This is what we call the uh, direct buried method. But there is problem may happen for this method. May not work well in dry or rocky soil. Dry or rocky soil, it may not work properly. So this but it's a simple method we are using in most of the houses. Okay, next method is a ground ring method. Ground ring method means like we are using a continuous loop of metal wire around the perimeter. You look at here this picture. Around the house, we're using the continuous loop of ground wires around the houses. So this is a method we're using is a ground ring method. So this ground ring method, we have to put the ground wire under the earth at least 2.5 feet. At least 2.5 feet. That's the one condition. And second condition is the ground wire should be more than 2 gauge size. So we have to, these are the two conditions. We have to put the ground wire around the conductor. So this give a more advantages because earlier we put the grounding rod only one location. Here is around the house, so it has advantages on grounding effect. Okay. Next method is a concrete encase method. So concrete encase method involve embedding the metal wire or rubber in the concrete foundation. So we put into the concrete foundation. Okay. So footing in the system connecting into the ground electrode. This method ideal for system that are mounted on concrete structure. So if the system is mounted in the concrete structure, so this method is more feasible. So this method is more feasible when you have the entire area is concrete structure. We have a concrete structure, then we using this method, concrete encased method. So we can use this to ground our system. So here the grounding electrode conductor connected to the neutral bus in main panel. This is what we say the bonding is happening. So we say the neutral ground bonding that has to be grounded over here. So you got the idea. So this neutral bond earlier also the every methods, but the neutral conductor in the bus bar to be grounded here. That's the idea here. Okay, this is grounded here. Okay, so this is the distance of the rod should be at least uh, the size of distance and 2 inches. Okay, we don't need to go specifically about the size and other things that during the design part we can do. So the general idea what is mean by these methods we are giving. So key functions of grounding system. Why we do grounding? Now we are looking at why we do grounding. Protection from the electrical shock. First one is protection from electrical shock. Grounding provides a safe path for electricity to travel. So safe path for electricity to travel if there is a fault or short circuit, basically short circuit. So we are providing the, I already said, we are providing the easy path. Okay. And stabilizing the voltage level. Grounding helps to stabilize the voltage level during the normal operation. It ensures that voltage is evenly distributed throughout the system, because by using the grounding we are referencing the zero voltage. The grounding is always a zero voltage potential. So we are indicating, we are giving the zero voltage reference to the system so that it is stabilize the voltage. So next one, preventing the equipment damage. As I explained earlier, if lightning strike or any other power surge occur, grounding help to directly direct the excess energy into the earth. So this is a matter, like if there is no grounding, what happens is that when the lighting or any excess discharge occur, then the metal or your equipment metal body has to receive all the discharge and it will start to burn or damage. So usually that is the case. Like if there's no grounding system, then your the appliance or equipment itself has to receive all the the lighting strike or any surge uh, which falling on the which coming through the wires or into the system. So what happens, like if any sudden exceed too much of electricity falling into the system, the equipment has to receive everything if there is no ground. So if you have a ground, then the excess will be diverted in the ground. So it's protecting the appliances. So component of electric grounding, what are the components? Electrical, the grounding electrode we call grounding rod, we know that. The galvanized steel, copper or galvanized steel, these are the low resistance material, low impedance material. We have to use this material. Grounding conductor, we have to use a grounding conductor. There are specifications to select what size of grounding conductor. That on the job you can learn that. So but grounding conductor is another important thing. Then grounding bus bar. So we have a bus bar, grounding. Then the bonding, that a bus bar is a common point. We know that bus bar is a common point where we can ground the system. Then the bonding we will teach you another subject as another video. Bonding means that neutral is connected to the ground. Like bonding is used to ensure the metal part of the electrical system are connected to the ground, preventing the potential difference between them and ensure the non-electrical carrying metals parts are safe. So bonding is like all the wires, the grounding system is connected. Like we have to bond all the grounding points so that the all the appliances, all the equipments are connected in the grounding system. So bonding mean is connecting in between the system. Okay, that's all for today. Thank you very much. Please, the purpose of this video is to provide the a clear understanding about a basic understanding of grounding system. In future video we will give more detail about the grounding system. Thank you very much. Please subscribe this channel and continue providing your support to this channel.